Okay, here we are, chapter 3, and this is part 3. Let's jump in and talk a little bit about logical operators. When we're working in Java, commonly the bang sign equals means not. Two ampersand signs means and two pipes mean or, and then the caret is exclusive or. What does this mean? So we can take a look at this truth table for operator not. Again, the kind of the more common term now for this is bang. So if we have a variable, let's say p, and we have p by itself, if it's true, and then we add the bang in front, it turns it to false. If p is false, and we add the bang, now it's true. So whatever is done here in the parentheses, whatever result comes out, this bang is going to reverse it. Not sure where that came from. You gotta love the pen sometimes. It has a mind of its own. Come on. All right, so back to what we were saying here. So if the age, and we're saying age up here is 24, is greater than 18, is false because age of greater than 18 is true, but this guy makes this now false. Does the weight equal to 150? Well, we know up here that we're saying that weight is 140. So this is false. And then this takes this and now turns it to false. Oh, I'm sorry. I got the... See, this is how even the best of us can make mistakes. So let's try that again. Is weight equal to 150? No, that's false. So this takes that and turns it to true. So yes, it is true because this is false and the bang reverses it. Sorry about that. Gotta love it. So now let's take and talk about a truth table for the operator, the double ampersand sign, which we know is and. So in this case, if P1, come on now, if P1 is false and P2 is false, then P1 and P2 is going to be false because both of these are false. So both are false. If one of them is false and the other is true, we're going to get false again. Same thing here, because one of them is false, it's going to be false. The only way when you're using the and sign to get true is if both are true. So again, age here is 24 and weight is 140. So is the age less than or equal to 18? Well, that's false. And the weight less than 140? Well, that's going to be false too because we don't have that sign. Instead, we have this sign, which is exclusive, and 140 is not less than 140. So that's false. Because both are false, this is false. And we can go through these conditions, and simply the reason why there's no example here is because this is the same thing. They're just saying, uh, at least one of the variables has to be something other than true. So whenever you have that, you're going to have a false because, again, for us to get a true response, all items must be true. So if we have true and true and true and do it 100 times, but then the last and is false, then all of this is false. Now, with that being said, I think on the next slide, nope. In a couple slides, we're going to talk about this symbol being really unique and that it will only continue to look at a compound comparison. This, by the way, is a compound comparison. Let me pick a different pen for this. So this is a compound comparison because we have two items here. This particular and says we'll continue to keep looking at each condition until we reach one that is a false, and then we stop. So let's say we have true and true and true and false and true and true. Well, the code is going to come in and go, okay, so far true. It's going to look at the next one. So far true. Okay, that's good. Look at the next one. True. Yep. Oh, this is false. And it's never going to look at these at all. This is known as short-circuiting. You are short-circuiting your if statement. We're going to talk a little bit more about this here in a moment, but just kind of keep that in mind. Now let's look at a truth table for operator OR. We've got the OR statement. When we go up here, we can see that this is known as the OR statement. So when we have a variable, and again, we have to have two variables. We've got P1 and P2. If we have both variables false, then we're going to get a false. If we have a false and a true, it's going to be true. And if we reverse those variables, we're still going to get a true. And if we have two trues, we're going to get a true. So it's almost the opposite of the and. And what we're saying is, for us to get a false result, all of the conditions have to be false. All it takes is one true in the statement, and you get a true. So again, it could be false, 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 true, and this entire thing will be true. Now let's look at the truth table for the operator. Again, this is known as the caret on many keyboards. We call it the exclusive OR. So it's a logical exclusion. So what does that mean? Well, in this case, we have two variables. If we have a false and a false, we're going to get a false. If we have a false and one true, we get true. Again, if you change the variables, but you still have the same idea here, and that is one of them is true, then we're going to get the true. But if we have two trues, we get a false. So that's the truth operator for the exclusive OR. Now, in this, we're going to talk about using just one ampersand and one pipe instead of having the two. We're only talking about one. And what does that mean? Well, as I was telling you before, when you have two of these in the and, it's going to keep going. So it's going to do this one first, and then this one second, and it will keep going as long as it keeps finding trues. So if this is true, it will go on to the next one. If this is true, it will go on to the next one. At the point where it hits a false, this is going to stop. Why is that? Because in our logic here, we know with the and signs, the only way to get a true is that they're all true. So as soon as it hits a false, it knows that the result is going to be a false. So in this example, this very first example, our compiler, when you're using the double and, would say, oh, this one's false. There's no way for this statement to be true now. There's no way. I don't care what comes next. It cannot be true. And so therefore, it's going to stop right here. It's never going to even look at this statement. It's going to just go ahead and automatically shortcut or circuit back to you a false. Same thing with the OR. The only way you can get a false in this is if you get all of them falses. So as soon as it finds a true in one of the variables, it knows to return back a true. So it will keep going as long as it's finding falses. The moment it finds a true, it stops and returns true. So again, in this statement, if we've got false or false or false or false or false or true or false and so forth, once it gets to this true, it stops and will not evaluate the rest of these conditions. However, if you use just the single operator, Java will go ahead and continue to look at the other conditions, even though it doesn't have to. Well, why would we want to do that? Here's the real good example. Let me erase some of this. The real good example, the reason why, is in this case, we actually have something happening in the condition. So not only are we comparing, but we're actually telling our code to add 1 to this x. So every time this line of code is evaluated, x add 1. Now, there's a little bit of a problem here, though. If we use the two ampersand signs for the and this is false, this never happens. And x, let's say x is 4. If we use the two ampersand signs, x, after this line is ran, is still going to be 4, because this never happened. However, because we're using the 1 ampersand sign, it will say, oh yeah, this is false, but because we're using the 1 ampersand sign, we're going to still go ahead and evaluate this actual condition. And by doing that, it's going to let this x++ actually happen. So after this line of code, x is now 5. In this, because we're using the double and, x still equals 4. Well, technically, if we did this line first and then this line, x would not equal 4. X would equal 5, but not 6. If we ran this with just one ampersand sign, then x would equal 6 because this would have happened. Same thing with the or. In this case, we're saying if this proves out to be true, then don't go any further. Only false would it go further because it's looking for a true. So false, no, false, no, false, no, true, hey, hey. But in this case, let's say that this is a true. It will never run this. And so if x, let's say in this case is 5, right? We're still going with this. X is 5. Then x still equals 5 because this never ran. However, let's for a moment say that that this never exists. If that's the case, then if this is true, it's still going to go ahead and evaluate this statement because we're using only one or sign. All right, so in the next video, we're going to start out and we're going to start talking about the switch statements. Similar to an if statement, but slightly different because we like to keep it interesting here at Java. All right, I'll see you on the next video.